flexibility due to the flight issues today. So this first video in the series for remote class tonight is going to cover joining and plotting XY coordinates. So as we discussed at the end of last class, there are a multitude of ways to get data into ArcGIS. And last week we focused fairly extensively on creating it yourself. So creating a shapefile and then editing that shapefile in either Pro or desktop as a way of creating a new piece of data. A lot of today's skills are going to focus not on using Editor, but on imagining you already have the data you need, it's just in a different format. So someone maybe gives you a list of XY coordinates or gives you a piece of data about neighborhoods but without the shapefile boundaries, or someone gives you a list of addresses. What we want to cover today is effectively how you can take those pieces of information and then using the skills in Arc Pro and desktop get those to be a piece of spatial information. So we'll start with joining. I'm going to open up the demonstration in Pro and have you follow along with me. So once you've opened Pro and started a project, remember the next step, always want to try to add a folder connection. I don't know where you're going to be storing your data. I don't see your computer. So you'll simply just navigate down to whatever folder. I like to pick desktop, because that way I have all my options here. Oops. Next step, under Insert, I'm going to make a new map where I'm going to be holding the information for this video. Right, remember in Pro, whenever you create a map, there's no real defined projection just yet. It's going to temporarily have this Mercator projection of the whole world until you drag data in, and then once you drag your data in, the world will conform to that identity. So, the next step that we would do, I want you to open your data folder from today, and I'll have the data organized after this by, video 1, video 2. So in the video 1 data, you'll have a Philadelphia neighborhoods file, so drag that in. And in the video 1 tables file, you'll have one that says neighborhood data, and you'll want to drag that in as well. So anytime you have a piece of data, regardless of what program you're in, remember I recommend a solid starting point is to open the attribute table and examine what you're looking at. So in this instance, we happen to be looking at a neighborhood shapefile. We know that it says the name of each neighborhood, how many homicides happened there, how many burglaries, the size of it, and so on and so forth. And that's definitely good information. But let's pretend that someone gave you this. They handed you another piece of information that was a table they had recorded that has the names of certain neighborhoods. Now, I've given the fields weird names like donut and cheese to make the point that what we're about to do has nothing to do with the names of the fields. The fields can be named whatever you want to achieve a join, which is what we're going to do, but what matters is the information that's in there. And so they've given you a table that we cannot see spatially, but that happens to list the name of the neighborhood and has information on the population, the number of people who owned, and the number of people who rented. So this is a really good piece of data because we could theoretically add this to our regular neighborhood here and be able to understand the number of burglaries per properties, right? That way we could see, if an area that has 204 burglaries, is that just because that neighborhood has a ton of homes and so there's just greater opportunity, or burglaries per population, but we can't see that right now. So anytime that you want to join data, the quickest and most effective way to be able to do it is either click on this data that emerges once you've highlighted your shapefile, and add a join here. Or if you've preferred the right-clicking of this class, right-click your file and add the join. A window will pop up, and it's going to be asking really for only 4 things, because that's all you need when you're doing a join. The first thing you're going to need is you want to know who I'm joining to, right? Well, I already clicked on that. I'm joining to Philadelphia. Second thing, jump over this one and come to the join table. This is essentially asking you, where do you want to get your information from? Well, there's only one other thing here, and it's neighborhood data. But if you had more data, you would select out the one that you want. We want to join to the neighborhood data. And then the last thing it's going to want to ask you is the names of the fields. Right? Within each of these data sets, there's going to be an attribute, a field name that contains the same exact values. What are we working with here? We have a map name. If we jump over to the neighborhood data, we have 2 fields. We have donut and cheese. Now, they both appear to be the same thing, but the reason I've created them is because cheese will not work, but donut will. And the reason for that is the cases. So when you are joining data, case matters. Uppercase values need to join to uppercase values. Lowercase values would need to join to lowercase values. At the end of this series of videos today, you'll learn a couple of skills using what's called field calculator for how you could change that if this is a problem, like if you only have lowercase in one data set and uppercase in the other. That's not a hurdle. There's ways to change that using field calculator. But for right now, your first step anytime you join is make sure my fields are identical. And in that instance, donut will match to map name. So let's do that. In Philadelphia neighborhoods, I want map name. It's pretty smart. It picked donut for me, thankfully, by looking. Might have picked something else, but let's just make sure. And hit run. And what you should see is when this is done, more fields will fill out in this attribute table. Notice how it just grew, and now each one knows its population. How many owned, how many rented, right? And then the other fields that came past. Super powerful, super useful tool, right, that allows you to grow your data sets. Now, it's important to know that the join we've created right now is live. And what I mean by that is that if I right-click and go to join, and I hit remove, it will disappear, right? My data sets won't be joined together anymore. It's a good practice, in my opinion, that once you've joined data and you want to use it as a unified data set, right-click your data, and go to Data, Export Features. Think about this as literally making a copy. So all you'd be doing is finding where you want to save that copy. I'll call it neighborhood or nay with data. And then if I were to click nay with data, for example, I can't remove any joins because the data is firmly joined together, right? Versus if I go to neighborhoods and I say join, I could remove it and it would no longer be there. But here we are. Everything is sort of kind of saved. Now this is an unfortunate flaw that can happen sometimes when you're putting the fields, is that they come over and they forget the name they had when they attached. It's just like a weird, unfortunate kind of thing. But if you go to fields, hopefully their aliases came with them. And if not, that's a bit of a flaw. So something you might just have to do is, essentially, that is a big flaw with Pro. So I'm realizing something here that sort of makes life a little bit harder. Just to give you a sense of what happened here. If I redo the join, and I join to neighborhood data, donut to that, and I run the join. I hadn't seen this before, right? Notice that they retain themselves here, but there seems to be a problem that when you export them, they take on a very different kind of name. Right? They say, like, I was the fourth field in the Philadelphia neighborhood shapefile. I was the first field in the neighborhood shapefile. That's a bit of a flaw that doesn't exist in desktop. It happens here. So let's say for now, keep in Pro your joins active like they are now, so that you don't have to run into that trouble. If you want to see if you're doing this in desktop, the process is not at all different. You would right-click the data you want to join to, right? The muscle memory may look different, but the skills are the same. Right? I want to join map name to donut. There you have your donut kind of joined with the map name information. And again, this is what I wanted to do in Pro, data export. I'm going to call it NA data update, because this has never been a flaw previously in desktop. Right, notice here the names don't switch, right? They keep and retain sort of their names. So again, this is something I'll be digging into the bottom to why that happens in Pro. But for now, when you do this activity for class or for anything else and you're joining in Arc Pro, just make sure to leave the joins live, right? Leave them at a point where you could right-click and say join, remove all joins. Cool, so then the next thing that I'm going to want you to do, so that's joining, right? We'll return to it considerably throughout this semester, but primarily what you need is 2 identical fields to match your data. So the second way that we could get data in your September 7th folder, you should see something that says crimes. And if we grab crimes in the table and drag it in and open it to examine it, right, it was a list of all the crimes, I think, in Philadelphia. You know, gives you a sense of, you know, what time it happened when the report was reported. They pushed that hour down to a 24-hour cycle here. They give you the block that it occurred. They tell you what happened. And then most importantly, you have your coordinates here. Hopefully some students, in addition to watching this, are also going to be watching the videos on either of my channels on plotting XY, just because it contains some important nuances that I'll touch in this video, but that you may want to have further clarification about. When you're going to plot XY coordinate, knowing what units your coordinates are in is critical. These are the most common ones. You'll see the numbers range between -180 to 180 on the X, and between 90 and -190 on the Y. Right? And if I were to open PowerPoint really quick, you know, and just literally make a super easy kind of small presentation to show what that means, those numbers. Like, so I'll take a line and I'll draw, pretending I'm like graphing the world right here. And there's my kind of Y-axis, and here's my X-axis. Apologies again if it's not perfectly equal. Right, so if we imagine that this is 0 right here, right, the world would be 0, then this is sort of like North America, right, and South America, or parts of South America, right? This is the equator, and then the other one would be the prime meridian. And if you think about that, anything then west of the prime meridian would be a negative number, right? So between 0 and -180. Anything north of the equator would be a positive Y number between 0 and 90. So therefore, if you did have a point that was like -75 and 40, Negative 75 and 40 would be like negative 75 and 40 would be like right there, right in the heart of North America. Versus if you had something that was kind of a negative number and then a negative number would be down here in South America, or a positive number and a negative number would be down here in Australia. So that's all those mean, right, when they're telling you negative 75 and 40. I'm cautioning you because you may see data that looks radically different. You know, there might be an example of this later in the video, but you may see like it's reporting itself by like 10 different numbers. And the coordinate might actually be in feet or in meters because that's the way it was calculated. It's just important to know that for what I'm going to show you next. Here we know they're in XY. And here's why that's important. So if I right-click crimes and I go to display XY data, that's the way you do it. It'll be the same muscle memory in desktop. Automatic, where it is. I can tell you where I want it to be saved. You know, it's totally up to you how you want to do that. I'll call it crimes. Oops. It's going to ask you here, where is the X value being stored? Right, I'll say you're in the point X. It's asking where the Y value is being stored. You're in point Y. And here's the last step, and it is absolutely critical in both Pro and in desktop. What this is asking you is not necessarily what coordinate system do you want this to be in. It's asking you, when I look at those values, when I see negative 180 or negative 75 and 39, what does that mean? What values are those actually showing me? Is that a decimal degree or is that a projected coordinate system? Now you're going to be pretty good in Pro. Pro will usually default to this, right? It'll come up as GCS, World Geographic Survey, which is what this background map is. And those units are in decimal degrees and everything will be all right. But if it defaults to something else, like let's say it defaulted to that, because that's the coordinate system of your neighborhood file. Remember, as we learned last week, so we could open our spatial reference and see that you're projected in a Philadelphia or Pennsylvania centric way. But what's most telling is that if I drag myself to the end of it, it's feet. Everything is depicted in feet for that. So that makes sense when we talk about measuring the distance between several points, but it's also going to report the coordinates in feet, right? Imagine just a conversion. Somebody gave you Celsius and you converted it to Fahrenheit. Somebody gave you meters and you converted it to feet. In this instance, in that coordinate system, it looks at decimal degrees and it converts them to feet. So the problem then is that if we do this, it would fail. You would never see the points. So you can try it on your own if you want. And the reason is that it would be looking at this data and it would see negative 75 and then 40, and it would think negative 75 feet and 40 feet. So that means like wherever the XY coordinate or wherever the two axes cross each other for the Pennsylvania coordinate system, it would be going like only negative 75 feet and only 40 feet right from the middle. So it'll be nowhere near Philadelphia. So just make sure if your coordinates are in that, you want to go here and you want to make sure you're picking the World Geologic Survey in Pro. And that way, if you hit run, it will fail. Okay, what is the problem here? So I wonder if it's maybe the way that I saved it might have been the problem. So I'm going to come up here and I'm going to instead try to save it just in my project folder. Try to do that. Maybe it was the way I was saving it. Give that another shot. Beautiful. So I was just saving it in sort of the wrong place. Okay, so I've plotted the crimes. Let's zoom back and see if it worked. Maybe these weren't in Philadelphia. So if I right-click and I zoom to the layer, they are a strangely backwards version of Philadelphia. So I'm going to have to dig in here and see exactly what the issue is.